Hello, good morning, good afternoon, good evening, everyone. Thanks for joining us at this wonderful workshop, Building Kubernetes Operators with Ansible. I am Chris Short, Principal Technical Marketing Manager on the OpenShift team at Red Hat. I'm joined today by a few of my fellow Red Hatters and then some of them in spirit as well that have contributed to the work behind here. So Michael Rivnak is here with us today. Melvin Hilsman and Rose Crisp are acting as lab assistants. If you need help with any of the labs later, you have questions, they're here to help us. Matt Dorn has spun up infrastructure for us to test with. He, excellent guy. He helped me out last night when I had some issues with a Kubernetes cluster that I was trying to show a demo on. So super thankful for that, Matt. But we're very excited today to talk to you about building operators in Kubernetes with Ansible. And I think we need to get started by just level setting a little bit. If you need help with anything, we have breakout rooms available that I can drop to Melvin and Rose as needed, and they can help you one-on-one in these breakout rooms. In addition to that, if you have any questions, please feel free to use the Q&A box. That really helps us that really allows us to target questions as opposed to them getting potentially lost in chat. Chat, feel free to talk amongst yourselves about what you're trying to accomplish, what you're trying to do with Ansible in Kubernetes, and what you're trying to gain from attending this workshop, I think is also vitally important. So please, network, communicate with each other. I think that'd be great. Also, we have some polls queued up, and I'm going to fire off the first one. If you feel free to answer them as you see fit. If you are watching this on one of the live streaming networks, keep in mind that you will not be able to participate. You will need to have registered for Red Hat Summit at summit.redhat.com to actually interact in the same way that you would normally with this workshop. So yes, if you're here in attendance, we are live streaming this as kind of a grand experiment for live events. And what can we do with them, and how can we tweak things, and just learn overall, right? Like, we're all here to learn these days. It's a wonderful opportunity to learn new things. So without further ado, let us get started. So if you don't take away anything at all about Operator Framework other than this slide, you've gone a long way, right? So keep in mind that there's a Google group for Operator Framework, and there's a Kubernetes operator channel on the Kubernetes Slack. So if you have questions about the operator framework, those are two great places to go. I am Chris Short. I'll be introducing what Ansible operators for Kubernetes are to y'all. I run OpenShift.tv, and you can follow me on Twitter at Chris Short. You can also throw questions at me that way, and I can get them answered for you as well. So let's talk about the Ansible operator, or the operator SDK makes it easier to deploy and manage. The Ansible operator SDK makes it easier to deploy and manage Kubernetes applications with Ansible support. So that's like the topic of the whole workshop, right? Like, operators help simplify the deployment and management and operations of complex applications on Kubernetes and Red Hat OpenShift. Operators are usually written in Go, but there is this Ansible-based capability that is now in the operator SDK and has gotten vastly improved upon because of a lot of hard work done by people in the operator SDK community on the Ansible K8s modules. So if you've used Ansible and Kubernetes together and over 2 years ago, try again. The modules and everything are completely different now. So thank you to Fabian and all the wonderful Red Hat engineers that worked on that. So in my opinion, and in a lot of people's opinion here at Red Hat and elsewhere, Ansible fits naturally into a Kubernetes environment. And that might seem a little awkward, but let's compare the two, right? Like, let's look at them individually. Both bring joy to users through orchestration and automation, right? Both are very widely used, very, very vibrant, active projects, right? The GitHub Universe report last year, I think, had like Kubernetes is 7, Ansible is 8, or like 5 and 6 or something like that on the overall activity of the entire GitHub universe. So they're vibrant communities that work on common problems too, right? Like, when you go to Ansible Fest, you're talking to engineers and people trying to solve problems. When you go to KubeCon or any kind of cloud native event, digitally these days, it's the same group of people usually trying to solve problems. So that's it's great. Like they're both wonderful mindsets, and they both kind of jive together. And then kind of to add the cherry on top, they both use YAML to describe the state of the world. So if you understand YAML, all you have to do is learn a little syntax, and that's the difference between Ansible and Kubernetes, basically, right? Is some syntax and obviously the purpose and orchestration and, you know, all the APIs and everything of Kubernetes. So, I mean, to give you kind of a YAML to describe the state of the world example, on the left-hand side here, you see a Kubernetes manifest for a config map. On the right-hand side, you would see, or you see the Ansible version of this done with a K8s module. But bonus, you can now templatize it because you have Jinja 2 available to you with Ansible. So instead of actually having to specify the color red, you could then have you know, labels or tags or some sort that could, you know, say this environment has this variable of color, and, you know, your staging can have red and your production can have blue, right? You know, for example. So now templating is available to you just immediately, just by using Ansible out of the box, right? That might not be like a great experience for you, you would think, but when you can do something like this to call all your YAML definitions for something, right? Like if you had a YAML definition for your entire application stack in one, you know, nice, you know, bundle of things that had to be done in a certain order, right? Like doing a lookup like this, just in the right order, is a perfect thing for Ansible to do. So you could then templatize it. Sorry, went back wrong. You could then templatize your Ansible and have a, you know, potentially better experience in that regard, because templatizing things using Jinja 2 does actually save people a lot of time, we've seen in the Ansible community. So let's get to the meat and potatoes. Stateless is easy, stateful is hard, right? With Kubernetes, you get a lot of powerful functionality. It makes it relatively easy to manage and scale simple apps and API services right out of the box. But because these applications are usually so stateless, and Kubernetes functionality and APIs and, you know, deployments know how to scale and recover from failures, and they have specific knowledge, there's what do you do with the state, right? Like everything lives eventually somewhere, you know, on a disk, in a database, somewhere, something at an end state, there is some piece of data that you're trying to hold on to. You know, writing, you know, 12-factor apps and making them just kind of very event-driven, that is what Kubernetes is great with. The idea here is that doing things with state is a little bit harder with Kubernetes. And this is where operators enter the picture, right? The operator can instantiate some human knowledge, some human operational knowledge, that's why it's called an operator, to do things with state, or in the event of things changing state in a way that you don't expect it, or that you would appreciate that it didn't. Again, apologies on the slide conversion here. So the operator SDK, like I said, encodes human operational knowledge. The idea is that it's going to automatically patch, upgrade, recover, tune, you know, scale, whatever you need to do with your app on an operational basis for you, with, you know, events being the trigger for it. So if you've ever seen the Kubernetes event log, you've probably watched it like fly by like it's the Matrix or something. So having to actually manually trigger something and manually do something at Kubernetes speed is actually a lot easier to do with operators, because it is watching the Kubernetes event file itself, the event logs itself. So they enable kind of automatic day two management, right? And when I say that, I mean, instead of being reactive, it's proactive. Instead of checking for anomalies and responding to PagerDuty, manually fixing things, your operators are going to be proactive and continually adjust, you know, the declared state that you have given the operator. Now, if you're writing operators, you're going to find that they act very quickly, because they are acting at the event of Kubernetes events. So at that speed, they will then operate accordingly. So you should see pod failures responded to accordingly, you know, rather quickly. if you're seeing operator type usage. So it's nice because you don't get that page because the service is already recovered by the time that a detection of some anomaly or some lack of, state being there, some lack of API being present, the pod might have already recovered by the alert being triggered. So let's look at what an operator kind of looks like under the hood. Moving left to right, you have the K8s API, the Kubernetes API. You have some custom resource in your application state, and then a controller, which has two kind of things underneath it. It has the event watching capability, and it has a reconciliation loop. And that reconciliation loop is what occurs when the watch event is triggered, right? So you're watching for things based off a group, a version, and a kind. We'll talk about that in a second. So that GVK group, version, kind, you'll see a lot in this presentation because those are things that trigger the reconcile loop. And that reconcile loop will then put your Kubernetes application into the state you want it, into the state you declare it. So that's why we say operators declare the state of your application, because if you run an operator, your application should run. If something happens to your application, it should return to that state. So question from the live stream, are slides available? Yes, I can get them to you. We actually have them somewhere from previously. I just don't remember, so I'll have to look that up for you. Moving along. So recently, last week actually, the operator SDK and, the operator SDK, which is part of the operator framework, and the operator lifecycle manager, which is also part of the operator framework, were donated to CNCF. They are now incubating projects, and they are, can be used for any kind of Kubernetes environment. And so we're super excited about that. A lot of work, a lot of effort has gone into that. Several of my friends here at Red Hat were involved in that, and I'm very, very happy that it is finally in like the CNCF ecosystem of projects. Yeah, here we go. Thank you. Matt dropped the link for slides. Stand by. I will copy and paste that into chat here. Ta-da. There you go. All right, slide for everybody. The operator metering piece, that's more of a cost management kind of function. So the CNCF wasn't necessarily interested in donating that. We weren't necessarily wanting to donating it either, but it's just perfect. I think what you need, the operator lifecycle manager that actually manages the operators as like a group. OLM manages the lifecycle of operators and their dependencies and within your cluster. That piece you need, and then you can actually add in Operator Hub with that piece, and then you have access to hundreds of operators that can just run right now on your cluster. Pretty awesome. So super excited about the donations there. So what is making what is an Ansible operator? What is the Ansible operator SDK? It's a collection of building blocks from the operator SDK that enable Ansible to handle reconciliation logic for an operator. So Ansible is a first-class citizen in the operator SDK, which is awesome. It's been available since, the fall of 2018, and the operator SDK assists Golang, Helm, and Ansible, all as languages to be written in to build operators with. So how do you use it? Well, you kind of use your existing Ansible logic, or you build Ansible logic for your, environment in a containerized or Kubernetes-ified state. And you do an operator SDK new with the type of Ansible. Let's just run through that real quick. So well, before we run through it, let's talk about, you have your operator SDK new, it builds out a framework, a scaffolding, you add your Ansible content to it, and then you build your operator with it. And that operator then is now, launchable as Kubernetes manifest files. So why build operators with Ansible? Existing skills and the ecosystem, right? Like Ansible has not just the K8s module, which interfaces with Kubernetes, and the whole K8s family of modules that interfaces with Kubernetes APIs. It has that ecosystem of tools like for cloud services, for network devices, for your edge devices. A lot of the things that people are using for Ansible now still have to be touched in a way, like your application still might need things done in a certain order. Database has to be up before the application server, before the web server kind of thing, right? Like that stuff still applies. But in the cloud native world, it's kind of like everything launches at once. And maybe your application doesn't like that. And maybe writing it to do so isn't necessarily something you're going to be able to take on right now, but you need to adopt Kubernetes in a fast way. Here's kind of that gap bridge kind of deal. So you're using the same Ansible tooling, the existing skills, with that low barrier to entry, the both having the vibrant ecosystems, and the declarative state of definitions like Kate's definition files go hand in hand with Ansible. The abstraction layer on top of Kate's API can also help people embrace Kubernetes if they already understand Ansible. So if you kind of see the world through the Ansible lens already, you can start seeing the Kubernetes world through the Ansible lens as well, which is kind of nifty, I think, if you approach it like that. If you needed more reason, right, like we have an awesome mascot, and if you ever see us again, any of us that are presenting this workshop today, if you ever see us, we will have a sticker, and I forgot to put on this shirt this morning. The shirts aren't available for sale right now, sorry, and we don't have stickers available to give you because, well, I'm here in my office in Detroit, and you're at home or wherever you are. So, but next time you see us, hit us up. We'll hand you some stickers. Say, hey, I went to your virtual workshop in July. Hit me up with some stickers. I have them in my laptop bag already, ready to give out to you. All right, so let's talk about like the operator's capability levels and what you can do, and kind of like what are like 5 phases of operators we kind of think are. Phase 1 is that basic installation of an application, right? Like apply, kubectl apply, here you go. Phase 2 is seamless upgrades, right? It manages patches and minor version releases and so forth, so on. Phase 3 is that full lifecycle application management, talking about storage, backups, recovery from failures, any kind of, oddity, recovery, anomaly, correction kind of thing. Phase 4 is deep insights, metrics, alerts, log processing, workload analysis, right? Like it understands your operator understands some application knowledge, some application logic that it can then do something about. And then phase 5 is autopilot, right? Like it can scale itself, it can tune itself, it can, completely correct itself from any abnormality that you could possibly imagine. And what you'll notice is, right, like we say we have support for Helm and Ansible and Go, but Helm only can take you so far, and Go is kind of like a high barrier to entry, right? So Ansible kind of fit very nicely in the middle there, as kind of being that sandwich between, yeah, I know Helm and I can build operators with Helm right now using my existing Helm charts, but I've got everything written in Ansible. Why can't I just reuse my Ansible? Well, there's the solution. And, you don't necessarily have to write everything in Go. Now, with that being said, Helm and Ansible will have a performance hit compared to Go, because Go is a low-level programming language where Ansible is an abstraction, as is Helm. So just keep that in mind. If you're like tinkering with operators and you're realizing like, this is kind of slow, well, there might be, your application might be high performing and have some need that the Helm or Ansible operators might not be able to satisfy. So just keep that in mind. There is some performance reduction when you use another abstraction layer. All right, so what does an Ansible operator look like under the hood? All right, again, you have on your left, moving left to right, you have your Kate's API, you have your custom resource and your application state. You have an operator SDK binary, which uses this thing from the Ansible Tower project called Ansible Runner. It's just a very, machine specific way of driving Ansible operations, right? Like, so you don't necessarily get all the bells and whistles of the Ansible command line tool. It's just the ability to execute roles, playbooks, and some other Ansible basics in a programmatic fashion. You get a watch file, which allows you to specify what you're watching for, that group, version, and kind, again, as I mentioned. And then you include playbooks or roles. And that package then becomes your K8s application. And applying that, YAML will stand up the entire environment for you for whatever the operator is designed to do. So let's look at what developing your first Kubernetes operator with Ansible looks like. Step one, obviously you have to have the operator SDK installed. So in a lot of operating systems, that is as simple as brew install operator SDK, like on a Mac. I'm pretty sure most DNF and Yum-based repos have operator SDK somewhere. Typically, your automation will leverage the Ansible K8s module itself. So you might want to have Ansible installed on your box just so you have the K8s modules available to you. And yeah, remember you can use Ansible both inside and outside of the cluster. So if you want to use K8s to then, do some things and then have another step execute something outside the cluster, you have the entire Ansible module library. Question from chat. So Ansible is as Go full support for the operator, including autopilot. I saw some slides which showed Ansible more in the middle in the past. Not sure what you're talking about there, Rockhound, but it is in the middle of the chart. Maybe it wasn't full-fledged in the past, where now it is. Depends how far back you're going in the operator SDK lifespan there. Give me some context around past. I just know what the present is. Moving right along.
If I may, Chris,
go ahead, Michael.
Yeah. I think early in the history of the Ansible operator, that chart did have a different reflection of Ansible and how far the capabilities went at that time. That was more a function of it was just so new, we hadn't really tested out and proven out how far it could go. But since then, and I feel like it's been, probably at least a year since we did prove that out and adjusted that chart as you see it today.
Yeah, at least a year. So yeah, it's fully supported now, Rockhound. So yeah. The slide holder contain, another note from chat, Matt. The slides folder contains placeholder for demo exercise pages, but does not link to any GitHub repos, etc. to follow along. Sorry. I do have a GitHub repo somewhere. I will dig it up as soon as I'm done talking, so you can kind of see what I'm talking about. So yeah. How do you initialize your operator with Ansible? Operator SDK new, just like you always would with any new operator. You specify an API version, that V, part of that GVK, group version kind. So in this case, we'll just call it, we're building a memcache operator. We'll call it a memcached operator. We'll say the version is cache.example.com v1 alpha 1, because we're just tinkering with this. The kind is memcached. So again, that watches file will reconcile on an event for kind memcached. And then the type is the important part here. That type flag is Ansible. And when you do all that, it actually builds you out this wonderful skeleton. It creates the Ansible role skeleton. It creates a pre-baked watches.yaml file based off the command you entered. Creates a CRD, deploys the CRD deployment manifest for the operator, and gives you some basic tests for Molecule, which I think is really cool. Molecule is a pretty cool project that we adopted, Ansible adopted right when I joined Red Hat, like in 2018. So it's pretty cool to bring in a unit testing tool like Molecule and then have it like pre-built in the operator SDK for Ansible. So having those basic tests there that you can build from allow you to test your operator as you're building it. And if you do a tree on that directory, this is kind of what it would look like. Some files you might notice, a Docker file. There's the CRD under deploy. There's that CRD definition file. A requirements.yaml. That's worth noting because if you have like roles from Galaxy or roles from your local GitHub repo that you need to pull in first, you can specify those there. And then you have the actual role or playbook under the roles file or roles directory itself. And then at the very bottom of the list is that watches file that I will show you here in a second. So basically, just by running that one command, you get 17 directories and 30 files. You don't have to touch all of those, but most of those are the molecule stuff for unit testing. So we recommend that you do spend some time trying to get some good unit tests out of your work if you're looking to go a little more full-fledged with Ansible operators. All right, so let's take a peek at that Docker file. Are there any Ansible versions that depend on specific Kubernetes versions? The K8s module docs page for Ansible has what version it's compatible with. I think it's compatible pretty far back. So I wouldn't worry about, specifically with the operator SDK, don't worry about any Ansible Kubernetes versions problems because Ansible Runner is programmatically designed and baked into the operator SDK itself. So that image that you get, peeking at the Docker file here, that image that you get, the Ansible operator image, has the Ansible Runner executable in it. You can pull, it then pulls in all the requirements from your YAML file. It then installs those, pulls in the requirements YAML file and then installs the collections or roles from Ansible Galaxy or wherever you can modify this file to pull it from wherever you specify. And then copy the watches file over, copy the roles over. So all of this is going to be baked into your container at that point, and this is what your operator is going to be, based on, essentially. Mapping Kubernetes events to Ansible automation. That watches file is so vitally important. And that is what maps your Kubernetes objects to your Ansible automation, right? So associating that Kubernetes group version and kind to that Ansible role or playbook. This is the glue there between the Kubernetes events and when your role or playbook will run, when this operator will trigger, essentially. So the operator SDK binary watches the cluster for events matching the defined types in this file, and then executes the associated content when an event occurs that matches that group version or kind. So as you can see here in the watches file, version is specified, v1 alpha 1, group is specified, cache.example.com, the kind is specified, memcached, and the role is actually the name of the role we put in the operator SDK itself. So back on this screen, you put the role in the roles file, and that's what it's actually triggering here in the watches file. So yeah, that's kind of the watches file in a nutshell. So what does the custom resource, that CRD, look like? So the spec is actually translated to Ansible extra vars. So if you had some variables that you wanted to define at instantiation time, you could do that here in the spec file, and they would show up to the role as extra vars. So this is a way to specify variables at another level in your Ansible kind of ecosystem. The status will have generic status recorded by the Ansible operator itself. So this will use the Ansible runner output to generate meaningful information for you, the user. Like this is the actual Ansible output that arrives in the status. So you will see that changed, failed, success output that you're used to in the status of the CR itself. So yeah, kind of nifty. So what happens when you build your image? You run that operator SDK build. Well, it pulls the image down, pulls all the things together, runs the Ansible Galaxy collection install of your requirements, copies over the watches file, copies over the roles, and then it's built and tagged and everything you want if you tag it appropriately. And then you can push that to a repo, or you can test with it locally, however you see fit. But yeah, it's operator SDK new type Ansible with your group version and kind specified, and then operator SDK build once you've got your Ansible content, your unit test how the way you want them. So that is a simplistic view of things, but it's a nice way to kind of introduce you to it. So what do you do after that? Well, you deploy your Kubernetes manifest files. kubectl apply -r-f deploy to recursively deploy those files that are all the YAMLs that are generated. That'll create your RBAC, your service accounts, your CRDs, deploy the operator to the cluster itself, create the custom resource itself, and initialize the operator, as well as running those basic molecule tests. I've gone way over my time, and I'm sorry, Matt. I'm very sorry about that. But explore more operators at operatorhub.io. And thank you very much for listening to me drone on about this. It's one of my favorite topics. And I really appreciate all the work that has gone into this from every Red Hatter and every upstream contributor. So thank you so much. Over to you, Matt, for Module 2.
Hi, everyone. My name is Matt Dorn. I'm a principal engineer here at Red Hat, and I'm going to talk to you about operators. I know Chris just did a great introduction about operators and what they do and the power of Ansible Operator, but it's totally possible that those of you who use Kubernetes day in and day out still may not know what an operator is. And guess what? That's okay, because it's not the easiest concept to get right off the bat. It takes some familiarity not only with Kubernetes, but the back-end workings of Kubernetes, specifically the API. So what I'm going to do here is share out my screen. One moment here. Okay, so you should be able to see my deck here.
Yes.
And let's talk about operators. Cool, thank you. So what is an operator? Well, you look up the formal definition, you go do a Google search for this, it's going to come back and say an operator represents human operational knowledge and software to reliably manage an application. But what does that mean? What are we talking about? Well, if you run, for example, OC, and by the way, for those of you that don't know what OC is, for those of you who just use kubectl, OC is a lot like kubectl, but it's specifically designed for OpenShift. It works just like kubectl in that it sends API calls to the Kubernetes API, but it also has some extra benefits, extra features that are specific to OpenShift. So this is just like running kubectl. If you run this command, OC get operators, right? You're going to get a response back, in most cases, that the server doesn't have a resource type called operators. So operators really aren't like a Kubernetes resource, right? It's really just a nickname. It's really just a nickname. To really understand that nickname and where it came from, we have to go back a few years. So let's go back to November of 2016, right? November of 2016. This was on the CoreOS blog. For those of you that don't know what CoreOS is, CoreOS was a startup based out of San Francisco in the US that specialized in an operating system called Container Linux. Maybe some of you have used Container Linux in the past. Container Linux was an operating system that sole goal was just to run container workloads. There was an assumption being made there, right, that it just ran container workloads. It didn't have a package manager. It had auto updates turned on by default, and it wasn't really easy. It had mostly a read-only file system, right? So you could avoid configuration drift and things like that. Well, CoreOS was acquired by Red Hat a couple of years ago, and back in 2016, this blog was put out by Brandon Phillips of CoreOS, where when they started concentrating on their Kubernetes offering, that there was a brand new class of software called operators, and these were built for Kubernetes, and they had three characteristics. Those three characteristics were that they were a resource, they were a Kubernetes controller, and human operational knowledge. We're going to look at each one of these things we're talking about here. That an operator is a nickname given to something that has a Kubernetes resource, specifically a custom resource, a Kubernetes controller, and we're going to learn what a controller is in detail coming up, and operational knowledge that Chris was just talking about. So first of all, what's a resource in Kubernetes? We all know that a resource in Kubernetes are the things that we interact with. When you run the kubectl command line, if you run OC, when you talk to the API, the pod. The pod is the fundamental unit, right, that we interact with, right, for deploying our application. A pod can be one container or multiple containers, and those containers in a pod, what do they share? They share the same host name, they share the same inter-process communication, they share the same network stack, right? So pods are really how we deploy our application. We have config maps, great way to put configuration information or comp files and abstract comp files from our application. And then if we wanted our pod or application within our pod or container to consume that application information, you would simply bind the pod to the config map. And we do this via YAML objects, right? Also, how about Kubernetes routes? Routes. Some of you may be thinking, what's a route? I never used a route. I use Kubernetes and never used a route. A route is just like ingress in the regular Kubernetes world. It's a way for us to get access to an application that resides inside of a Kubernetes cluster. A route is just the name that we use in OpenShift for that. But the concept is the same. What about controllers? Controllers are running at all times inside of your Kubernetes cluster. They're always running, and they're ensuring things depending on what the controller does. Like, for example, the replica set. You all know about the replica set. The replica set is responsible for ensuring that a copy of a pod or the specified number of pods that you specify in your object are always running, right? Because we know we just don't want to have one. Two is one and one is none. We want to have multiple copies for high availability. Replica set controller watches the API and ensures that that is actually happening. And guess what? By studying the replica set controller, it's a great way for us to understand operator pattern, the operator pattern. What's another example of a controller? The daemon set. The daemon set ensures a pod is running on every node in the environment. If the daemon set controller gets notification that the administrator installed a brand new bare metal worker node or a new virtual machine worker node, guess what? Daemon set's going to see that new node, get alerted on that new node, and then go spawn that workload onto that brand new worker node. Could be a bare metal server, could be a VM. And then, of course, we have deployment. Deployments are great because they ensure replica sets are running. Not only that, but they also assist in server-side rollouts. Before deployments came along, we had to do replica set rollouts, let's say from version 1 of our app to version 2 of our app, all client-side. You can imagine having to watch and scale down and scale up pods. How about we just automate all that and put that into a deployment? That's why deployment controllers are great. And then, of course, we have the domain or application-specific knowledge. So we're utilizing, just to show you this, a custom resource, a custom controller, or we can use some existing controllers built into Kubernetes, and domain or application-specific knowledge. Now, that's not just installing. We know it's really easy to install stuff, right, in Kubernetes. You do a kubectl apply, you may do a Helm install, variety of ways to do it, get the thing running on the cluster, make sure it's running. Really easy, right? But what about scaling properly? What about if you have a stateful application, an application that stores state, right? Perhaps you use a persistent volume to ensure that if that pod goes down, right, it needs to come up in a particular order and retrieve its state from that persistent volume. Maybe not only does it have to grab that state information from its volume, but perhaps talk to its peers, talk to its friends, get health information, ensure they're getting the proper state. That is the cadence and rhythm of your application that only you know about, your stateful application, right? So you may want to program it to scale in a certain way, maybe differently than a stateful set does, or maybe differently than a replica set does, right? Only you know because it's your app. Self-healing. What happens when your operator goes down, or if, I should say, your application, maybe a database becomes corrupt? Is it going to be able to detect that and fix it? What about cleaning up when you're done using the application? What about updates? Updating your application from one version to another. What about backups, right? We understand that if we store our backups on the cluster and the cluster gets destroyed, we're out of luck. We need offsite backups. And of course, we're doing backups. We need to be able to do restores, okay? So that is this is the human application knowledge that Chris was talking to you about in the introduction that we want to codify and put into our controller. And we'll learn more about this coming up. So an operator really takes advantage of what Kubernetes does best. And what Kubernetes really does best is present a very well-structured API. The API is the unsung hero of the Kubernetes world because no matter where you go in the world, if you're interacting with a Kubernetes cluster, you know you're going to have that predictable schema of the API, right? If you build your operator to run in your cluster and talk to that API, it's hopefully going to be able to run in any other Kubernetes cluster. It has a predictable schema. It has a predictable way of behaving, right? And so how do we get access to the API and actually look at this in an easy way? Well, there's this kubectl proxy command. Great command for exploring the API and not having to put your credential information in every single time. If you can imagine, no one gets away really with talking to the API server without authenticating. So this authenticates you using your kubeconfig credentials and then sets up a local proxy. So all you have to do is hit localhost, in this case 8001, and now we have access to the API. You can see by hitting the API, when you run kubectl get nodes, kubectl get events, kubectl get config maps, you are hitting the API. And how are you hitting that API? You're hitting that RESTful API with RESTful verbs, right? Things like get, put, post, etc., right? That's the way we gracefully and elegantly interact with this API, right? We all love RESTful APIs, right? Easy to use, right? So what's the point of talking about the API and what do they have to do with operators? Well, we understand that when you hit a particular object on the API, you can get back the representation of that object in YAML format, very easy to read, right? We understand YAML is a superset of JSON, right? So this is much more easy to read. We don't have to worry about our curly braces and all that stuff right here. And we're looking at the DNS pod inside of a Kubernetes cluster, which is awesome at providing service discovery for us, right? To allow us to easily discover services in our cluster, within our cluster, right? kubedns allows us to do name lookups on that. So the API and understanding the API is fundamental to operators because remember what we said, operators, first of all, take advantage of custom resources or resources. So in order for it to be considered an operator, first and foremost, it has to use a custom resource definition. What is a custom resource definition? Used to be called third-party resources. What is it? They allow us to extend the Kubernetes API. Very, very, very powerful feature. Imagine this. You are literally extending the Kubernetes API. You are adding your very own API endpoints without having to go clone down the canonical Kubernetes API, add your own custom types or structs, right? Recompile, go publish it again so your users can, what a hassle that would be. You literally here can send an API call to actually extend the Kubernetes API. So let's go ahead and extend the Kubernetes API by creating our very own object and resource via custom resource definitions. We're going to go through this workflow very, very quickly. So keep in mind that if you want to revisit any of this stuff, we have great documentation online to show you this, but this will at least show you how easy it is to create a CRD. So check this out. Creating a CRD really just starts with the custom resource definition. Notice that the kind is custom resource definition here. Okay, so this is an actual representation on the API called custom resource definition. And you're going to be able to customize the name here. Notice that you're putting MySQL. So you're calling this API endpoint MySQL. And the group, in this case, is just DB for database.example.com. But that can be yourcompany.com, right? Because we might have multiple partners, customers, etc., organizations, companies, right, that may want to create a custom resource definition with the same name. Multiple companies may want to create a MySQL database CRD, right? So why not just have them use their company here, and that will allow us to disambiguate various kinds that have the same MySQL. And of course, we say that the scope is namespace. What that means is that once we create the actual MySQL object, for example MySQL or MySQL 1, that will belong and be scoped to a namespace. But this action right here that you're looking at on the screen requires usually out of the box or cluster admin privileges because you are literally extending the API. But you're going to learn that with the operator lifecycle manager, an upstream project that Chris mentioned that is part of operatorhub.io, you can easily install it on your vanilla Kubernetes cluster. Guess what? A regular user who just has project admin rights can actually run something like this. Not explicitly, but they can install an operator without necessarily having cluster admin rights. And we'll learn about that later. So let's go ahead and create this custom resource definition. And after we create the custom resource definition, we run the command kubectl get CRD. And notice when we run that command, it comes back and it goes, yep, I did it. I created the MySQL endpoint for you. And of course, running kubectl get CRD is the exact same thing as just sending a RESTful GET call to this API endpoint custom resource definitions and seeing that this MySQL object was created, as you can see down here. So we've created this CRD, but guess what the real power is? Now check this out. It's just awesome to see this. If you actually go and you say kubectl get MySQL, notice that kubectl understands the word MySQL now because it comes back and says no resources found. But when you see no resources found, you typically think, oh, this seems like something's broken. This seems weird. This is good. This means that your API endpoint is available, as we can see here. Now we can do a get, and notice that the actual API endpoint for MySQL is now available, right? But guess what? It's empty. We haven't created anything yet, right? So think of this like a class or something like that, right? This is a representation of this new resource or API endpoint called MySQL, and now we just have to create some items for it, right? Because we have a null list here. So let's go ahead and create a new database object. How do we do that? Well, we just say API version, and we put in the API version that we initially set up, and we put in kind MySQL, and then we put in what we want to call it. We're going to call this one WordPress. You can probably take a wild guess at what we're probably going to do here. We're setting up a database to be used for WordPress. And then notice how we're putting in information in here, in our declaration or spec. These are values that we want to apply to our creation of this MySQL application. Now, you may be thinking, how did the user know that these were the accepted keys? How did the user know that, it had to be a string or an integer? Where's the man page for all this stuff? With CRDs, you create the man page when you create the custom resource definition via the explain command. For those of you that don't know about the explain command, type in kubectl explain into any Kubernetes console, and you will see that you can actually program your own explain information for your custom resource definition. You can add validation information. You can add minimum and maximum values, so you can only accept particular values when you actually go and put in your spec. There's a whole bunch of powerful features you can use in custom resource definition. Right now, we're creating a WordPress MySQL object. Let's go ahead and verify the creation of the MySQL object. After we go and we actually create it, notice that now when we say kubectl get MySQL, it comes back and it says WordPress. And then if we said -o YAML, we get back our object. And of course, you got some other stuff in here because we know there are numerous other programs running in our cluster that update this information, like resource version, the UID, the things like that. But the point is that now we've persisted a new object on the API. But guess what, everyone? Guess what? That doesn't mean that a MySQL application is running in our cluster because we need this other missing piece. And guess what the missing piece is? The controller to watch the custom resource and act upon its presence. We need something in the cluster to see this custom resource and then have the logic to actually implement it, make it so. Without the controller, you just have an object on the API and nothing happens. So what do Kubernetes controllers actually do? They observe the current state of the cluster. So the controller sits in your cluster as a pod. And typically, the vehicle we use for deploying that pod is not just a regular pod by itself, because we know if that thing goes down, it's never coming back up. It's a lonely pod. We typically use a deployment as the vehicle for deploying our pod, to sit in the cluster and watch the API. What it does is it watches the API, and Chris talked about this, right? It gets an event when the object is created. So when our MySQL object gets created, the controller gets this event, and it triggers something called a reconciler. And what the reconciler then does is it looks at the current state of the cluster. It looks at what is true. It does an audit, and it compares that to the desired state. That's the spec section of your MySQL object, what you want, the username, the password, etc. And then it performs all the actions necessary to get that MySQL object created. This is where your human operational knowledge comes into play, into the controller itself. And thanks to Operator SDK, you can do that in Go, and Michael's going to talk about how you can do that with Ansible in a really, really easy way. So we can understand controllers by studying the embedded controller built into Kubernetes, the replica set. Great way to kind of study how controllers work, right? So what do replica sets do? We know that they provide redundancy, right? So if you're running multiple copies of your application, something goes down, it will spawn a new one, right? What else? How about scaling? How about when your application gets featured on TV? It gets very, very popular, and more people start hitting it, and they're just taxing your Kubernetes application. How are we going to go and take care of that? We use something like a horizontal pod autoscaler. When we scale out a brand new pod, right? Then the CPU load will go down. What else? Sharding. So running multiple instances can handle different parts of a computation in parallel. Think about this, just batch processing, right? You want to convert a movie file to something else? Just use multiple pods, spin up multiple pods to help do that job for you. So how do replica sets work? Well, look, just visualize a controller. Visualize a controller. So the replica set controller, right? You put a declaration out there that you want a copy of one replica. And then all of a sudden, when you have that copy of one replica here, you then go, the controller sees that declaration and does a comparison of that declaration to the current state. If we don't have any pods created, it's going to create one. Notice how it's using labels and selectors to keep track of the pods that it owns. Okay? It's using labels. Labels are really, really important in the Kubernetes world because they control the way that objects relate to each other, right? And we can change that relationship on the fly by manipulating labels. So labels are very, very popular, powerful and popular. kubectl scale replica set, my first replica set 3. We're going to change our declaration to 3 here. And what happens is this is an event. Because here's the thing about controllers. Controllers get events, and they're not just like regular Kubernetes events, like kubectl get events. We're using those, this is a different usage of that word events. Once you change it to 3, that's an update event. So the controller sees that update event. It also cares about create events and delete events. And then it triggers the controller to compare the declaration in the spec, the fact that it's 3, to the current state. And you can actually see that the current state right here is that there's only one pod. Current state is only one pod. So it's going to spin up 2 more pods. Okay? The replica set here in this case is the primary resource, and the things that it creates are pods. Okay? So that means that the replica set controller watches for the creation of kind replica sets. Right? So that's the primary resource for this replica set controller. The replica set control loop, it just runs when it receives an event. It finds pods matching the label selector. That's the actual state of the environment. It then does our comparison to match how many pods I currently have with our label selector to what is declared. If there's too few pods, then it'll create additional pods. If there's too many for some reason, it's going to delete some. And then, if it's just enough, nothing will happen. But this control loop gets triggered anytime there's a create, update, or delete event on replica sets. But not just replica sets, it also gets alerted from pods. So let me show you what I'm talking about. One more deeper dive into this workflow. And this is nothing more than a pattern. It isn't anything fancy. We're all in tech here, right? We're probably in tech. Understanding these patterns is really just key. It's a new pattern. That's really all it is. This book, Cloud Native Infrastructure, talks about this pattern. They call it the reconciler pattern, right? And they really talk about the idea that it will force the engineer to have 2 independent avenues for getting either of these representations. It's all about the actual state into the expected state. If you can get those 2 concepts, that the actual state is just the kubectl or the client running inside the controller, looking at what is the truth right now, as opposed to what is inside my YAML spec section declaration, and the logic necessary to make that current state meet what is declared inside the YAML. So check this out. We have a controller running, right? The controller watches for replica sets and also watches for pods owned by the replica set. So notice here that I care about pods owned by a particular replica set, because if I go behind the replica set's back and I delete a pod, I want it to respawn very, very quickly. Well, how would I know to do that? I would need to get an event. So that's why my replica set controller also watches for pods that are owned by a particular replica set. First thing that happens is a user creates a replica set. They say they want 3 pods. That creates an event that the replica set controller sees. The first thing the replica set controller does is get the audit or actual state. It lists all pods based off the label specified here. What happens is it says there's 0. It compares 0 to the actual state, which is 3, and what happens? We then create a pod. But then what happens? The creation of that pod spawns a new event, because the controller is also watching the API for the creation of pods owned by a particular replica set. What then happens is the replica set controller lists all pods by label. Okay? So 1 is less than spec.replicas. 1 is less than spec.replicas. Now what happens? We create another pod. That spawns a new pod, and then I'm going to create a list of pods. As you can see, that creates another one. And then when we do our audit, finally we're happy. Why? Because the declaration meets the actual state. And then the reconciler calms down and everything's quiet. And then, of course, what happens if we go and we delete a pod in our environment? We do another audit. We have 2. Let's go ahead and create a new pod, which creates another event. Now we're happy because the actual state meets the declared state. You all see that? So understanding this workflow is key to understanding operators. And of course, deployments. Deployments work the same way in that the deployment controller, as you can see here, when we watch for deployments and replica sets, when you create a deployment, what happens? The deployment controller sees it, creates a replica set. The creation of the replica set has the replica set controller. So these controllers can work together to ensure that everything is to your liking or to your declaration. Okay? So going back to our MySQL example, we need a controller running in our cluster to see the creation of the MySQL object, right? And then it creates our MySQL application. But guess what? Here's where the human operational knowledge comes into play. Because those of you who have used MySQL, we know it's not just as easy as creating a MySQL application or pod and then everything's running fine and great and we're done, we wipe our hands and walk away. It doesn't work that way, right? Even if we've been a MySQL admin in a traditional tech environment way before containers came along, think about all of the various tasks that you need to know to be a MySQL admin. This is all the stuff that you're going to put into your operator logic, into your controller logic. So you don't have to do all the work. You're going to codify all this, right? So you don't have to do any of the work at all the toil, all the manual intervention. You're going to put all of this in there. This is the human operational knowledge that we're talking about. So to recap, custom resource definitions plus custom controllers plus your knowledge equal operators. And why do operators matter? Because we want to build an as-a-service platform experience on Kubernetes. What are we talking about here? As a service. You all know when you use Amazon or you use Google Cloud Platform or you use Alibaba Cloud or you use Azure, when you want to create a database or create an application, it's so easy, right? You go to a form, you click a button, you put in some stuff that you want, the size and the quantity and the details, the name, and then it's done. And it just runs and just works magically. That's the experience we really want on Kubernetes. Build an ecosystem of software on Kubernetes that can be as easy, safe, and reliable to use and operate as a cloud service. Low touch, remotely managed, one-click updates, right? So you can imagine on a dashboard for Kubernetes, you would just click a button and the operator gets installed, right? If you didn't want to use the dashboard and you were kind of wondering what's really happening behind the scenes when you deploy an operator, well, the custom resource definition is being created because we need that API endpoint, right? That's the first request. Also, our operator has to be deployed. That's our controller. So now we're going through our various things that a operator is, right? So we have our custom resource definition. we have our controller, which is being deployed into our cluster via deployment. This is for etcd operator, by the way. And we go and we create our operator. So now we have our operator running the cluster, watching the API, waiting for the creation of our etcd operator object, right? There's our object right there. We're going to go create it. Notice that we're saying we want an etcd cluster. And by the way, this is for applications running on top of Kubernetes that want to use etcd, a key value store. This has nothing to do with the etcd that backs up Kubernetes. This is for your applications deployed on top of Kubernetes that want to access a key value store. We want a 3-node etcd cluster. Now, why is etcd a good fit for an operator? Because managing etcd manually is a hassle. I mean, it's a stateful applications. It's a database, right? A key value store. When you add new members to it, you have to do it in a particular way, in a particular order. Why not just codify all this stuff? And of course, once we create that resource, what happens? Our controller uses its operational knowledge to then go deploy an etcd cluster for us. So if we did an kubectl get pods here, we'd see 3 running. Probably not right away, right? Because remember, one of the key things about a stateful application built an operator, you're going to scale your way. You're going to scale what you think is properly. So in the case of this etcd cluster, the first master is going to come up, or the first pod will come up and be declared the controller, if you will, and then its peers will slowly come up and check in with the health with each other. So eventually we'll have an actual etcd cluster running. So how do you create your very own operator? Well, in module 3, I'm going to talk about that briefly, and then after that, we'll give it over to Chris for an example of actually installing an operator. But here's the most critical thing to really understand about creating your own operator. It's not easy, or it wasn't easy, I should say, for a very long time, and that's why the operator framework exists. It's not just as easy as declaring some resources that you want to watch and then writing some pseudo logic here, for example, getting the current state, comparing it to the desired state, and making it so, right? Because custom operators require many building blocks and boilerplate code. Okay. First of all, you have to understand how the client libraries work. These are ways of programmatically interacting with the Kubernetes cluster based off the programming language of your choice. But the reality is there's not a whole lot of documentation on how these things work. So they can be a long time to wrap your mind around how to use them. You have to have knowledge of informers and shared informers for object cache and event handling. I mean, think about this. You have tons of controllers running in a Kubernetes environment, even without operators. They all utilize caching to ensure that they don't overwhelm the API server. So you actually, for years, you had to set up your own kind of cache handling in your controller when you built one from scratch. And it's a little overwhelming to kind of wrap your mind around when you're doing it for the first time. You used to have to communicate desired state and actual state via annotations, track group-related resources, test scaffolding and repo organization. Here's an example of a project built with Client Go. This is a controller just from scratch. You can just see that we're just using Client Go packages and Go. So we really needed an easier way to create operators, and we needed an easier way to manage operators. And that's why we created the operator framework. Operator framework has all the tools you need for really making this a simple and nice to use process. The operator SDK is one of the projects within the operator framework, and this is what allows you to create an operator in Go or Ansible, as Michael's going to talk about later after the break. We're actually going to build one together in our workshop labs, and I'll show you that link coming up here. And Helm, right? So if you have existing Helm charts, you can convert those into an operator. The Operator Lifecycle Manager enables cluster admins to manage operators on any Kubernetes cluster. Really awesome project for providing an app store-like experience for your operators, but not only that, if you're running any sort of production Kubernetes cluster and you have multiple users interacting with it, chances are you're not giving everyone cluster admin rights. Probably shouldn't be giving everyone cluster admin rights, right? Especially the new intern. So how do you allow a regular user who may be locked to a particular namespace or project, as we call it in the OpenShift world, how do you ensure they can install an operator? Because even though you don't want them to have full rights to the cluster, surely they should be able to install an app to be more productive. Well, that's where OLM comes in. OLM actually allows a regular user to install an operator and CRD and all of the associated role RBAC and service, deployments and every secrets, etc., without having to have those cluster admin rights. Very, very powerful. Okay. And then, of course, operator metering for recording historical cluster usage and generating usage reports, right, over time. If you want any kind of billing or anything like that. You can check out operators. There are 2 operator hubs. There's one at operatorhub.io. All the operators you see at operatorhub.io will run in any Kubernetes cluster. These have nothing to do with OpenShift. You're not dependent on OpenShift. You can submit one to appear in Operator Hub if you'd like. And OpenShift, if you check it out at try.openshift.com, comes with the Operator Hub, an embedded one that actually has operators built to take advantage of all the cool stuff in OpenShift. Okay, check it out at try.openshift.com. And with that, I will turn it over to you, Chris. Thank you.
Thank you so much, Matt, for the wonderful walkthrough there. Really appreciate it. So I forgot to mention earlier, we're going to build in a break after I go through this piece here. We're going to have like a quick 10-minute break before Michael takes over to run through all the exercises. So if you feel like you need to take a break, give me 10 minutes, all right? So let's see, share screen here. I'm going to quickly walk through. I'm not even going to bother with slides this time. I'm going to quickly walk through using Operator Hub in OpenShift on a clean OpenShift cluster to install serverless for OpenShift. So this is a Knative-based operator, essentially, that can instantiate Knative serving instances and listening instances. So I am in Operator Hub, default namespace. Let's go looking for server. Come on, computer. You can do it. One too many S's, though. All right. Nope. Knative. My computer has never been slower, of course. All right, so when you find the operator, finally, you click it, and you see this quick overview page, right? Some operators will have some prerequisites. I know that this one has some that we can kind of easily work through here, because you can kind of stumble your way through these operators sometimes too. But I highly encourage you to read the documentation, but I just happen to know what's going to happen next. If you're familiar with Knative eventing and serving, check out, the OpenShift serverless operator. It's pretty dope. So let's install it and see what happens. I've been running this poll for too long. Hang on. So let's see. Update channel, we'll do 4.4 since I'm on 4.4 of OCP. OpenShift operators, I can't change any of that, so just hit subscribe. All right. No operators found. You can do it, I believe. Give it a second here. Let me fire up a new poll. Ah, there it is. Look at that. Operator just magically appears. Now, its status is blank. I wonder what's going on under the hood here. Let's go take a peek. It is created a few seconds ago. You can see the same documentation as before from when we clicked in Operator Hub. And below that, you can actually see the status, all the conditions here. We've got some pending states. So as soon as those go from pending to installed, we'll be good. That should already have happened. Assuming, go back to the installed operators page. Succeeded, yay. All right, so what can you do with that? Well, really nothing yet, but let's stand up a Knative serving instance. So let's click 2 buttons, create Knative server instance, and let's see what happens. Oh, not my notes file. That's brilliant, thanks, Mac. Create. All right, if we hit create, it says, oh, you need a Knative serving namespace. Okay, that must have been in the prerequisites. Let's just go ahead and create one from right here, just so we don't even have to leave the screen. Come on, there's no operators found here because it's brand new. All right, let's go back. We're now in Knative serving. We're going to create our Knative serving instance here. As we can see, Knative serving, both of name and namespace, they match. So it will, or should, create. So what's happening here? Well, kind of boring in the administrator view, but if you go to the developer view in the UI, you will see that it is busy cooking up some pods for you as it loads. You can do it, I believe. There we go. All right, so if you see some of these half spinning circles, they are going to go from light blue to blue, meaning that they've been downloaded and now they are running. That dark blue full circle is I am running, fully active kind of thing. Once this is all up, it looks like it is, we can hit the endpoint here. Walk past our certificate issues here, because why spend the compute on certs? All right, wow, we can download a client from here maybe? Wow, I'm on Mac. Okay, so yeah, there's the Mac client that I can download for my eventing server. Done. Yeah, you've just installed an operator with Operator Hub. Congratulations. You can dive into any of these pieces here just by simply clicking on them, and you can monitor each individual autoscaler component, or all the fun little bits and pieces in each pod. You can monitor and then meter accordingly, right? You see the memory usage from me jumping in here and hitting that instance and downloading the client. So yeah, having just clicked a few things, I now have a Knative serving instance up and running in OpenShift, and that makes me super happy that the demo worked. With that, I say we take a quick break. Michael, you're up next. Do you want to do 10 or 15? We are 10 minutes over right now.
I'm good with 10.
Okay, unless anyone starts screaming and says, let's push forward immediately in chat, we are going to take a 10-minute break, which means that will put us back here at 21 after the hour, which is 1821 UTC. So I will drop that in chat real quick, and I will see you all back here very soon. All right, 21 after the hour. Yeah. All right. It is exactly 21 after. I went ahead and changed shirts to the appropriate operable t-shirt for the event. My apologies for not putting it on earlier. Michael, you out there in Funland?
I'm ready to go.
Sweet. Hopefully everybody had a nice little break. Clearly, I have the appropriate attire on now for this. I apologize, like I said. If you want to go ahead and take it away, I can stop sharing my screen and you can let her rip, buddy.
All right. Do it. There we go.
Woohoo.
So plan forward. Let's see, I'll start with an introduction, and we're going to hit a few of these concepts again about Ansible and Kubernetes and how they intersect and really how in detail to use Ansible with Kubernetes. We're going to do an exercise to actually go through some of that hands-on. By the way, you don't need anything except your web browser to do those exercises. We have environments ready to go for you. We'll have the link in just a little bit, and all you need is your web browser, and that's it. So once we're done with that, then we're going to come back and talk about operators as they pertain specifically to Ansible. How in detail can we use the operator SDK to actually make an Ansible-backed operator? And then we will do another exercise and actually do that together. And hopefully that'll be time well spent. So first of all, an introduction from me. I've been at Red Hat for a little over 8 years. Just had my 8-year anniversary last month. I'm based in Raleigh, North Carolina. That's where our global headquarters is here. Normally, I would like to be coming to you from our office in downtown, but obviously I haven't been there in a while, so coming to you from my house. And let's see, I've been in the container space since really the early days of when Docker started coming around, and in particular when Red Hat first came of the mind and of the thinking that we need to get in on containers and container images, specifically figure out how can we make container images available to customers. I was involved in content distribution and repository management at that point, so got involved and helped out there, got into Kubernetes things as Kubernetes was initially open sourced, and Red Hat was one of the very early contributors to it, along with Google that started it. And eventually that turned into my full-time gig. Worked on the operator SDK itself for a while, in particular with a couple other people added the Ansible features to the operator SDK, and have been a big fan and advocate for it ever since. Most recently now I'm working on bare metal management and natively managing Kubernetes running on bare metal with no other virtualization layer, no other management layer, whatever, all baked into the cluster itself. Obviously involves a lot of controllers, a lot of operators, and even Ansible, of course, is in there in some places. So that's me, that's what I do, and I'm really happy to talk to you today in some detail and go through and put our hands on Operator SDK and use Ansible to make an operator. So let's dive in here to the K8s module, and we're going to review a little bit that you saw early on, but I think after hearing so much detail, particularly the explanations from Matt, really pulling the curtain back about how controllers work under the hood and how Kubernetes, how the API conventions even work, this is going to be worth looking over one more time. So here we just have examples of Kubernetes object definitions, just in YAML form, right? On the left, there's a pod. On the right, we have a service. And this is the kind of YAML that we could save to a file and run oc create-f, that file name, and it would create that resource in the Kubernetes API. Real basic stuff. This is the kind of world that we exist in as people who use and interact with and especially are managing Kubernetes clusters. It's YAML definitions like this all day long. Now, what if we want to manage those with a K8s module? So as Chris was saying earlier on, Kubernetes support in Ansible has gone through an evolution over the last several years. And early on, in particular, there were some early iterations that did things like utilizing a Swagger spec from the Kubernetes API to generate a client and some other things. If you tried those out, and I think those modules had slightly different names. There was a K8s raw, and I think there was another one whose name I forget. If you tried those out, you're in for a treat. Things have come a long way. And the K8s module itself is fully dynamic, really a pretty slim amount of code, takes advantage of really the Kubernetes API features that allow a client to be dynamic, and is just very simple and elegant to work with. So we're going to look at that now together. Okay, on the left, we have a config map, normal Kubernetes manifest defining a config map. Again, the same kind of thing that we could write to a file and run oc create-f or kubectl create-f. On the right side, we are using Ansible and the Ansible Kubernetes module as our client to create that config map. And you'll see that the YAML is exactly the same on both sides, except for the fact that obviously I took the opportunity to just templatize this color, really just to show off that that's something that's very easy to do. So you can take your own YAML manifest that you already have, that already works with your Kubernetes cluster. You can inline that YAML here in an Ansible task and immediately start using Ansible. Now, let's take one step back. What is a task in Ansible? Well, when you're programming Ansible, typically you do this as a series of tasks, one after another, that accomplish various specific things. And this is a task list, just like if you had a job to do, like a repair on your car, you'd pull out the service manual and follow a list of tasks to accomplish, or maybe chores around the house, or whatever it may be. In Ansible, we'll specify a list of tasks to do one after the next, and each one you can give it a name. So we've given this one a name, create foo config map, and then you say what module do you want to use, and in our case we're using the K8s module. Ansible is a very rich ecosystem of modules that you can use to do all kinds of things. Of course, Ansible has been around a long time, so it can interact with, classically, it's an infrastructure management tool, so all kinds of things around hardware management, network management, storage, databases, email, DNS, all these kind of network services. Ansible is great at that. Managing machines themselves in terms of software installed on them, firewalls, yada, yada. So there's tons and tons of modules that can do all those other kinds of things. But in our case, we're going to focus on the K8s module. And then we provide options to that module. And in our case, here, we're just providing a definition. And we're defining this resource by inlining the YAML right here as the definition. And that's really how this works. And we'll see as we go along here how we can compose multiple tasks together into a thing called a role. Now there's an even easier way and more straightforward way to organize your manifests in a way that Ansible can use them. This is my preferred way to do it, is rather than in your Ansible code, and of course as you're seeing here, I'm just assuming you're noticing this, that Ansible is YAML itself. Like we're defining all of our Ansible code as YAML. So it's a nice fit in that sense with Kubernetes. But here, rather than inlining the Kubernetes YAML inside the Ansible YAML, we can store a Kubernetes manifest in a file as a template. And we can use this lookup feature of Ansible, which many of you, if you're familiar with Ansible, you've probably used that lookup feature in other contexts. But here we're using that lookup feature to look up that template off of the file system. And then what Ansible will do is it will render that template using whatever variables are in Ansible's memory at the time you run the template. And of course, you can influence that by loading variables. You can set defaults in your role. You can load them from any data sources you want. You can pass them in at runtime. We're going to see later how we can pass in that kind of input variables from a custom resource directly. Pretty neat way to do that. In any case, Ansible here is going to use whatever variables it has in memory to render that template, and then the manifest that it gets when it's done with that rendering phase, it will basically apply that to the cluster, just like you saw a moment ago with the inline YAML. So here, imagine again, you've got your own manifest sitting on your laptop at work or at home, and you've figured out how to deploy some workload, some application in a Kubernetes cluster, and now you want to take the next step in turning that into something useful and reusable, something you can share with others. You can take that manifest and just put it into this Ansible role, like literally just move the file into this template, into a template directory in your Ansible code, and then start referencing it immediately with just these 3 lines of Ansible. And now Ansible can be your client to your Kubernetes cluster and immediately give you all these templating capabilities, which turns out to be pretty powerful. So here's an introduction to a role. Now, an Ansible role is a way of organizing Ansible code that's related, especially a lot of related tasks that are all part of a greater goal you're trying to accomplish, into one unit that you can package together, that you can distribute, that you can version and lifecycle and share in a standard way. So there are different tools that will scaffold out this role structure for you, and certainly the operator SDK will do that when it makes you your Ansible operator scaffold. But you really only need to know about 2 parts of this whole hierarchy to be very productive and get a lot of work done right away. Those 2 parts are these 2 in red. So under the tasks directory, there's a main.yaml. And as you might guess, this is where you would start putting those tasks, just like the ones we've been looking at. And then there's this templates directory, and that's, as you I'm sure have already also guessed, that's where you would start putting your template files that you're going to reference from a task using that lookup feature that we saw just a minute ago. And if you just know about those 2 areas, you can get an awful lot done. And then you can start branching out. And in fact, in the course of the exercises we're going to do, we're going to see 1 or 2 of these other areas as well. And so a role in traditional Ansible use cases might be something like, you could think of it like a role in a movie or a role in like a Shakespeare play or something. You would make a role that is, for example, web server, DNS server, application server, maybe a role that has some firewall rules. You might have a role that has your custom log sharing setup for your environment, where you want every machine in your environment to aggregate logs in a particular way to a particular place. You might make a role for that and apply that role to all the machines in your infrastructure. So you would make a role for all those different kind of things, and then Ansible lets you pick and choose. I'm going to take this logging role and the DNS server role and apply those to a certain set of, like, let's say 4 machines or 5 specific machines. In our case, with Kubernetes, we're going to focus on making a role that deploys a workload. So in this case, we have a role called memcached. So that role would, in theory, and we're going to do this in just a little bit, would deploy memcached into a Kubernetes cluster. And by first making a role that understands how to do that, that we can package and version and share and all these things, then we can take that role and package that inside of an operator using the operator SDK. That's our goal. Okay, why build operators with Ansible? I think we've already been over some of this today in this session, but as many of you know, many people already are familiar with Ansible and are already using it and may even have some assets that you can reuse. For example, if you're migrating workloads from some, I don't know, let's say more traditional infrastructure onto a Kubernetes cluster, or maybe several Kubernetes clusters, you may be able to reuse some of your Ansible assets that you already have. There's a certain skill set that is nice to be able to reuse if you already have that. And of course, there are a lot of things that you're going to continue to need to automate in your infrastructure around your cluster, and even parts of the cluster infrastructure itself that Ansible is a great fit for, with its rich ecosystem of existing modules. and there's a really low barrier to entry. I mean, look, I'm a software engineer. I like writing software. I'm the nerd that'll stay up late at night hammering away on some project that I'm just having fun working on. But I also like it when things are easy to get done. And Ansible makes it really easy to get an operator off the ground and add a lot of actually really advanced features for it. So there's no programming required. It's a very different kind of experience creating an Ansible role versus managing an entire software project written in Go or something else. I'm a big fan of Go. I tend to write Go most of my days, but I also really love an opportunity to take the easy path. Ansible, as we're seeing, we're declaring what we want. Ansible lets us express a desired state, and then it just makes whatever changes are necessary to get you there, just like a Kubernetes controller does. It's a really natural fit in that sense. Well, let's just keep going, and we'll see these advantages, I think, along the way. And with that, it is time officially for an exercise. So let's head on over to this website. This is learn.openshift.com/training. And that /training part is very important because at that link, we have provisioned dedicated infrastructure just for you, just for today, just for this session to ensure that there's enough capacity set aside. So anytime you want in the future, you can come back to learn.openshift.com and hit enter, and you'll see a boatload of exercises, including all these operator exercises and many other kind of exercises for all kinds of OpenShift things. You can do those in the future. There's no sign up required. It's totally free. You don't need an account. You don't need to give an email address, like nothing. You can just do it totally anonymous anytime you want. But anybody on the internet can do that anytime they want. And so for these workshops, we're provisioning dedicated infrastructure to make sure that no matter who or how many people show up on that public side during this next hour or so that we're working together, that's not going to affect you in the environment you're trying to work with. So learn.openshift.com/training should bring you to this page right here. Now you're going to hit Start Training on this Operator SDK module, and that will bring you to this collection of 7 exercises. And we are going to start with this Ansible Kubernetes modules one right smack in the middle. Ansible Kubernetes modules, and you're going to go ahead and click Start Scenario there. That'll bring you to this page where you can read this nice welcome message and a little description of what we're about to do. And then when you're ready, go ahead and hit Start Scenario. Sometimes you'll see this message like I've got. It says, hang tight, preparing an environment. No sweat, that usually only takes a few moments. And what we'll do here, the format we'll follow is I'm going to go through these exercises myself, and I'll talk you through them. But feel free to do them either at your own pace, feel free to work ahead, or if you want to just follow along with what I'm doing, that's totally fine too. Up to you. Either way, we'll meet at the end when we're done with the exercise and move on to the next thing together. And now, we're all just hanging tight. Maybe some of you have already gotten in here. So one other thing I'll mention while we're just waiting here, what you're going to have in your environment here is a big terminal on the right side, and that's a terminal to a real Kubernetes cluster. There's not emulation or anything. Like, it's a real, honest to goodness Kubernetes cluster that you have exclusive use of while you're doing the exercise. Very small, but it is yours. And this terminal gives you access to that. On the left side, we get the actual exercise content where you can walk through and see the instructions. And occasionally you'll see, right now it's blurred out while I'm hanging tight. It's taking a little longer than usual. You'll see this black box here with white text in it. And anytime you see that box, that's an opportunity for you to just click on it, and whatever that command is will automatically get put into the terminal and executed for you. So it's a nice little shortcut. In some of these cases, you'll see the task for you to accomplish is to like edit a text file or open a text file and add some content to it. Well, if you're doing that, uh-oh. All right, let's try a refresh here. If you guys go ahead and maybe put in the chat and let us know, are you having
problems? Yeah, if you're having issues, let us know. Is it possible we exhausted all the resources? I hope not.
Unlikely, but not impossible. Uh-oh.
Oh, you gotta allow cookies. You can't do that. Okay, some people on Twitch are saying it works okay for them. Works perfectly fine in chat here in the event itself. You, Gerben. Of course, you're the only one that's not going to get it, and you're just driving.
All right, I'm going to do what I told you guys. I'm going to do what I told you guys not to do. I'm going to go to the civilian, like the public URL, and see if I can get in there.
This is always fun. The demos.
Well, aha!
Okay, cool.
All right, sweet. I got into the public one. Fantastic.
I'm glad we set aside all those resources.
Yeah. With all that suspense, let's dive in. So here, what do we have here? We have this example Ansible role that's already been scaffolded out for us. We're going to interact with that role. It's just a very basic role right now. And let's see. So I'm going to do it the hard way. I'm going to use Vim. But like I said, in order to accomplish this first task where it says modify this main.yaml file to give it these contents, you can just click that link, and what it's going to do is, as you can see, it's just going to like download the correct file with the correct content off the internet and stick it in the right file on disk here and overwrite what's there. That's a fine, easy way to go. Just to kind of show you guys that there's nothing going on here, I'm going to do it the hard way. First, I'm a snob about Vim, sorry. Kind of my minimum for having a civilized experience here. Okay, we have this brand new tasks file with nothing in it. So we're going to add these contents. And what does this do? Well, we learned what this did a few minutes ago, right? We have an individual task. We have a name for it. We gave it the K8s module that we're going to use. And now we're just inlining the definition. And what we're doing here is, as you can see, we're creating a namespace, a Kubernetes namespace. We give it a name, and the state can be either present or absent. That's a feature of the K8s module. We can say that this thing either should exist or should not exist. And that's basically all we have for the moment. We got that in there. Now, to provide, so you notice we're using this variable called state. Well, we need to provide a value for that somehow. And we're going to provide that value by using this defaults file in our role. So right now it's empty. And here's an opportunity for you to just make up any variable names you want and provide default values for them. And there, like I said before, there's other ways to provide this input programmatically, and you can load them from different sources using Ansible modules. But here we're just going to provide a default value and take advantage of that. Okay. So we've done those two things. So now we're ready to actually run this playbook. Now, what is a playbook? Let's just look at this thing real quick. So an Ansible playbook is a way of basically telling Ansible to run one or more roles. You can give it a name. You can tell it what hosts do you want it to run on. So this is where, like, in the more traditional kind of infrastructure management, you might say, here's a list of host names, or here's some other way of selecting a bunch of machines that exist in the real world, and I want you to apply these roles to these particular machines. In our case, we're just running it on localhost because the K8s module is just a Kubernetes client, and that's what a playbook is in a nutshell. So let's go ahead and run it. While that's running, let's just point out that this is an OpenShift cluster that you're interacting with. It's OpenShift 4.4. Of course, as probably most of you know, OpenShift is Kubernetes. It is Kubernetes optimized and curated in a way that's ideal for enterprise use cases, but it really is just a Kubernetes cluster. We can see, yeah, we've got client version 4.4.0, we're running 4.4.8 as our server version of OpenShift, and that all corresponds to Kubernetes 1.17. So, OC is the client we tend to use, but you can use kubectl. In fact, sometimes when I'm bouncing back and forth between like Minikube or OpenShift or other stuff, I forget which client I'm using, and if you use the wrong client in the wrong context, it all just tends to work anyway. So back to Ansible, what just happened? We ran this playbook, and we see two tasks ran. This gathering facts task, which is just a default task that pretty much always runs, where this is Ansible gathering information about its environment before it runs any of your code. Then the task that we defined ran, where we set the test namespace to be present. And now looking at the recap of what happened, we can see that two things ran okay. That's good. Both tasks ran, and they're both okay. One task changed something, so there's a state change that it affected while it was running. And then everything else is zero, and that's good because these are all mostly bad things. So let's do an OC get projects, and there's the test project. Now you might be asking, Michael, I thought we created a namespace, not a project. Well, that's true, we did. This is an OpenShift feature, basically. OpenShift took the concept of namespaces, wrapped some additional multi-tenancy kind of features around them, the kind of things that would enable, for example, a development team to share a namespace with additional features that are useful to getting things done as a developer or a development team. And that whole concept is called a project, but really it's a wrapper around namespaces. So it's a long way of saying we told Ansible to create the namespace, and it did. Let's continue. Okay, now we're going to do something a little more interesting. We're going to leverage an existing resource file. So this is just like the story I was telling earlier of you might have an existing manifest on your computer right now that knows how to run some workload or some application that's meaningful to you in a cluster. You could take that manifest and drop it into an Ansible role and start using it. And that's what we're going to do right now with Nginx. So if we look again here in our local directory, we've got this Nginx deployment YAML file. If we look at it, it's just a normal deployment. Totally normal Kubernetes deployment. There's nothing Ansible about this. There's nothing Operator about this. There's nothing OpenShift about this. Just a totally normal deployment. It's running Nginx image. It's going to run 3 replicas. You know, you could take this and add a service probably to it, or an ingress, maybe a config map or a secret to provide some configuration if you got more advanced pod disruption budgets. You could imagine all the kind of resources you might put in here as you grew the maturity of deploying this workload. But for now, we've just got a totally normal deployment manifest that we're going to start from. And I'm going to take the lazy option on this command at least and just click it to run. So we copied that file into our example role. So now that we've put that in the templates directory, now we just need to reference it from our main tasks file. Let's go in there again. We have our first task. And now we're going to add second task. Is this stuff right here. I'm sure you recognize we're going to use the lookup feature. So look up that template off the file system, render it, and apply the result to the cluster. That looks good. All right, time to run this again. And like I was saying, with these environments, they are kind of small and they're kind of modest. So typically you would see Ansible run a little bit faster, certainly in a production cluster, quite a bit faster than what we're seeing here. But in any case, it did run. This looks good. There's a third task here, a new task, example role. It said it changed something. We see 3 OKs, 1 changed. So that all looks like what we would expect. And in fact, if we just ran that again, we can demonstrate that we're going to see 3 OKs, and we should see 0 changes this time, because presumably that deployment already exists. And then we'll go ahead, yep, so 0 changed, so that's what we expect to see. Then we can notice get all, and we can see that we have our deployment. We have the 3 pods that it created. There's the replica set that it created as part of the deployment. So everything worked just as we expected. Ansible loaded that template, rendered the template, and actually created this. But you might be thinking now, well, we didn't actually templatize anything. That's kind of a shame. We didn't take advantage of any of the templating features. Let's do that now. That's step 3. So we're going to modify this defaults file again and add a new default. We're going to give it a value of 2. Right now you saw there are 3 pods available and running, but we're going to set this now to a default value of 2. Again, you could just click that link for the easy way, but I'm going to do it the hard way. And now, of course, we need to go into our role and our template and modify this template, but instead of having a hard-coded number here, the number 3, we're going to read this from that variable. Again, this is a really trivial example, but you can start to see, at least conceptually, how easy this is. We just started with a manifest. We're just templatizing it now, and we're passing a value in, again, in the trivial, easiest way using a default value. But it really ends up being quite powerful as you do this for more and more parts of your manifest. Now let's run this again. And as soon as this is done running, what you're going to do is run this OC get pods. So I'm ready to click on it as soon as Ansible's done running, because what I want to do is catch one of those pods in terminating state. Yeah, there it is. So one of those 3 pods is terminating. Because there were 3 of them, now we set that default to 2, and of course it's going to scale that deployment down to have only 2 pods. If we run again, now that terminating one is gone, and everything worked the way we expect. Now lastly, this one just does a little bit of cleanup, but there's actually an interesting feature going on here. We can pass in this extra vars command line option to provide these variables on the command line. That's kind of interesting. In fact, I'm just going to take a moment, and what we could do is say, you could set that Nginx replicas to 4. I ought to see 4 pods then show up. So this is yet another way that you can provide input when you're running Ansible and provide input to your templates or other logic. Of course, in Ansible, you can use these variables for branching logic. You can make decisions by evaluating expressions in very complex ways and either do this thing or do that thing, depending on the state of the world or whatever you want to check. So here's a way to pass in those variables. And here we see, in fact, it did create 4 more pods, but they're not going to live for long. So I'm going to click this last command, and it says state equals absent. And what it's going to do with that is basically ensure that the resources we defined using the K8s module are not present in the cluster. Okay, it made those changes, and I think we're good. So we can continue, and congratulations, we made it to the end of our first exercise. I wonder if I'm still, this thing is still not healthy. I'm gonna keep reloading it just for fun. Okay, so we made it to the end. I'm gonna click on the More Scenarios button, and for the moment, we'll go back and do a little bit more learning, and then do our final exercise where we actually make an operator. So let's plow forward. Operators with Ansible. Of course, there's the operator SDK that makes this all possible. I think between Chris and Matt, we've already covered this topic pretty well, but Ansible is just such a good fit for the operator model. This ethos of we want to automate as much as we can, and especially day 2 management, all the things that a human operator might be doing to maintain workloads and infrastructure related to a Kubernetes cluster. We want to automate all that and bake that into an operator that is reactive and reacting to state changes and changes in the world in real time. So that's what we're doing, and Ansible is a great fit for that. So we know what a custom resource definition is, right? How amazing this is that we can add our own endpoints to the Kubernetes API. This is what Matt was teaching you about earlier. And here we're just seeing an example of a memcached resource. We're going to see this come up again in our exercise. So we created a new resource, a new endpoint called memcached, and we're going to use that resource to describe what should a memcached deployment be like. And in this case, it's very simple. It's like the most trivial example you might find for specifying a size of 3. You can imagine this could get very complex. We see operators and controllers that have custom resource definitions that get very verbose when you're talking about deploying something like etcd or maybe MySQL or Postgres or some other kind of complex data store, other kind of workloads. You can imagine this is like an installer. This is really collecting, here I go with my scroll wheel. Sorry about that. Here we're really collecting in the spec all the things you might collect in an installer for a piece of software when you were going to install that software on your computer or on your cluster. That's how we use custom resource definition. And again, this CRD is going to map directly to a role in Ansible. And here we see again what Chris pointed out earlier. Let's just do a quick review that we've got this Kubernetes API service that lives over here on the left. And it knows about some custom resource type that we defined, let's say memcached, that a user of some kind is specifying desired state for that resource. And this controller is watching events, and it sees an event come in that the base says, oh, look, there's a memcached resource, and something changed about it. Was it created? Was it updated? Was it deleted? We don't really care what the event was. We just know that something changed. It's just time to reconcile. And in this reconcile loop, as Matt was describing, it's going to see what was specified in the spec of that resource. What is the desired state of the world? It's going to compare that to the real state of the world and then make changes to the real world to bring it closer to that desired state. And in our case, of course, for an operator, usually they're used to deploy and manage workloads. So out on the right side will pop an application and whatever resources are necessary to make that application happen. Now, when Ansible gets involved here, it starts to get interesting. So really, at the core, what is the Ansible operator? Well, the work that we did to enable this, to really make Ansible operators possible, is we created a generic operator. We wrote it in Go using the operator SDK, for Go operators. And what it does is, instead of having a big reconcile function where you write a bunch of Go code that does that reconcile logic, that implements all this resource creation and state comparison, all that kind of stuff, instead of writing all that in Go, it just calls an Ansible role or playbook that you tell it to. So all it does is it watches events. You tell it what resources to watch events for. So in this case, you'll say, I want you to watch the memcached resource. And you express that in this watches file, in fact. So it's watching for events, and it gets an event, and it sees, okay, I got an event for a memcached resource. What do I do now? It's going to look in this watch file. It's going to find in this file, which is a mapping of resources to roles, it's going to find that resource in this file, and notice that in that file it says for the memcached resource, here's a file path to an Ansible role, and it's going to run that role. And it will pass that entire custom resource into the role as input. So all those variables, everything that was in the spec, is available inside Ansible as a variable that can be used to render templates or make logic decisions or evaluate expressions or whatever you want to do. Pretty neat. Let's keep going and see a little more detail on how this works. Now, we could spend an awful lot of time, let's say that, talking about some of the really advanced features and powerful features that Ansible operator brings to you, and some interesting ways in which it works. I just want to highlight a couple of things here that are really useful to know. Anytime you're making a controller, or an operator is a special kind of controller, it's very important that your controller has a cache of whatever resources it's watching and listing and interacting with. There's so many controllers running in a given Kubernetes cluster that if every one of them was hitting the API service on a regular basis, especially during a period of high activity, and doing completely new listings of collections and getting entire resources and so on, you could really basically DOS your own API server pretty easily. So it's a best practice and almost even like a must-have feature for a controller that it should maintain a cache of the resources that it cares about. And Operator SDK, by utilizing controller runtime as a library and some other things under the hood included in client Go, there's all these different layers of Go features that, well, you don't really have to worry about since you're an Ansible operator author, but they're under there. There are these libraries that enable you to, relatively easily plumb these features together and run your own cache. But what we're doing here is we're doing that for you in this reverse proxy. So when your Ansible code runs, we start up an Ansible interpreter. It's a new process, so it has no cache, it has no pre-existing state. But instead of connecting directly over here to the Kubernetes API, instead, your Ansible code talks directly to this local Kubernetes API proxy that runs as part of your Ansible operator. That enables us, inside that Go binary, to run a cache that your Ansible code will use just transparently. It has no idea that it's using a cache. Doesn't matter. Doesn't care. But we're able to bring that feature to Ansible operators by using this proxy. We're also able to do some other interesting things, like add automatic owner references onto resources you create. There are some other features we can do that probably just don't have time today to get into, but suffice to say that's one of the more interesting aspects of the architecture here, is we do run this API proxy as part of the Ansible operator binary. Okay, let's just keep going here. Here's an example of the watches file. Now, like I said, that watches file, it's a series of entries just like this. Here we've got an example with just one entry, but we've got a group, version, and a kind, and we're mapping that group, version, kind to a playbook. And like I said, a full path on disk to where that playbook exists. Of course, this is a path inside your operator container image. So your operator is going to run as a pod inside your cluster. You're going to make a container image that has your operator in it and has your roles and playbooks. So here you could specify a playbook or you could specify a role. But either way, you provide a full path to where that thing exists on disk. And that's it. Now, in this watches file, you can take advantage of additional advanced features. There are things like automatic finalizer support. That's something you can do here where, well, probably don't have time to get into that in detail either, but suffice it to say, if you know what a finalizer is and you need to use a finalizer, which is a relatively common thing to want to do as a controller, we make it real easy to do that, and you basically just turn that feature on here in the watches file, and it'll just work for you. So let's keep going. Operator decay things you've already been introduced to. You've already seen this, but again, I'll just emphasize, we've done some really advanced operator implementations and controller implementations using Ansible. It's a very powerful language, very easy to get started, really easy to get started. I think that's how it honestly got so popular. People started automating little bits and pieces of their infrastructure, and they realized, wow, that was real easy. Let me try this next thing. Wow, that was easy too. Let me try the next thing. Man, that was easy too. And before you know it, it's 11 o'clock at night, and everyone else has gone home, and you're still automating things. So in any case, really easy to get started, but also still very powerful, and you can go all the way through this capability level. In terms of the actual layout of your resource and how this works, just a quick point to emphasize, well, two key points to emphasize. One is in the spec for your resource, a user can specify as many key value pairs as they want. And these key value pairs get passed directly into Ansible as variables at runtime. So if you, in your spec of a resource, say like color : red, then that variable, that key and value pair is going to be available inside Ansible when Ansible is rendering templates, when it's evaluating expressions. You've got a direct pipeline here from the spec of a custom resource in Kubernetes all the way into your Ansible code, which is really cool. That's just a seamless, I think, I'm kind of biased, but I like this stuff a lot. I think it's really easy and simplifies a lot of stuff. The fact that you can go directly from the Kubernetes API and provide input directly to Ansible, that is really what Kubernetes native is all about. We're plugging into this one control plane, management plane of the API service and using Ansible as the logic to back an API endpoint. It's really easy stuff. Okay, and then the status, the Ansible operator will add a default status for you. It's generic, of course, and it basically looks like those statistics we were seeing at the end of a run, 3 things were okay, 1 thing changed, yada, yada. But if you want to have a custom status and put more directly meaningful things that are meaningful to your workload and your API, you can absolutely do that. We're not going to go over that now, just from time perspective, but you can do that if you prefer. And now I really want to emphasize how little there is in terms of assets that you need to provide to make an Ansible operator go, and we're going to contrast that with a Go-based operator. So everything in this gray box is provided for you. That's all available in the base image that the Operators Decay group and project provides. So the binary's in there, Ansible's in there, all the libraries it needs are in there, Python's in there, Ansible Runner is in there. That's a programmatic vehicle for running Ansible. You probably noticed that when we were running Ansible in that last exercise, the output was really very human-oriented, right? Well, Ansible Runner is a programmatic vehicle for running Ansible. So all that stuff is provided in the base image. All you have to maintain. So now we're thinking about what assets are you going to have in your version control? Like what's going to be in your Git repo that you need to keep track of, that you need to maintain, that you need to fix bugs in and lifecycle and all that stuff? Well, it's very little. All you need to provide is 1 or more Ansible roles, just like the ones we've been looking at, and a watches.yaml file that ties those together with a resource. And that is your operator. So think about the difference between that versus, and again, I'm a software engineer. I love writing software. I love writing Go all day long. But dealing with a whole Go-based software project or any other, like traditional programming language kind of project, there's a lot of assets to keep up with and a lot of stuff to do, a lot to maintain. You've got to be keeping up with versions of all your dependencies. You're vendoring in all of your dependencies and trying to keep up with all that. You're fixing bugs, and you've got tons, like just a whole sprawl of code that typically a team of people is dedicated to maintaining and enhancing. Well, as we've seen with Ansible in more traditional use cases, typically speaking, it's much easier for a small group of people or even an individual to keep up with and maintain some Ansible assets as opposed to accomplishing similar tasks using a traditional programming language. So when you think about assets, when you think about what kind of resources you have in your organization to work on operators, to create them, to maintain them over time, typically we see that it's easier to deal with Ansible assets. Often there's less red tape to cut through with Ansible assets in terms of getting sign-off for releases and other kinds of stuff. And typically it takes less employee power to make that happen as well. So you can do more with the people that you have, which is typically a good thing. Okay, let's keep going. When we're going to initialize our operator, we're going to run this operator SDK new command and specify -- type Ansible. We're going to do that in just a minute in our exercise, which is right now. So let's jump back over. Let's see, did I ever get, I did. See if I can use the real infrastructure. So we're going to go into the Ansible operator overview exercise. Ansible operator overview. Again, we've got this nice welcome page. I'm eager to, okay, it's telling me to hang tight, so. All right, forget that. I'm going to bail on that. Hopefully you're already in. We'll see which one of these comes up first. So once you get into this, here we go. Now we're getting live. You'll see that there are 8 steps here, but I have good news for you. The first about 4.5 steps are really just reading material that teaches you the things that we already went over. So what we're going to do is just fast forward past these first few steps, and we're going to click this little arrow up here. Step 2, 3, 4, all the way to step 5. We're going to scroll down a little bit until we see running operator SDK new. We've got this dark gray box where we can start running something. That's where the exercise starts. And again, I'm going to walk through this myself live. We'll talk our way through it. You're welcome to work at your own pace if you prefer, or follow along with me. One way or the other, we will meet together at the end. Again, I am a Vim snob, so I'm going to make this livable for us. Thank you for tolerating that. Okay, and with that, time to run this operator SDK new command. We gave a name for our operator, we said the type's Ansible, and we specified a group version and kind, and here's our old friend memcached. What kind of stuff just got created? Well, let's run the tree command and see what we have here. So we have this memcached operator directory. So let's take a quick tour. So we have this build directory, and there's a Docker file. This is a Docker file for your operator. Grab a little coffee. This is a Docker file for your operator to build your operator's own container image. Now we have a deploy directory that goes along with that includes your actual CRD, so it already scaffolded out for you the CRD itself. There's an example resource that you can use for like testing and development purposes. It's just a convenient way that you can go ahead and just have a resource to create. In the operator.yaml, this is the deployment definition for your operator. So again, you're going to build your operator in a container image and run it as a pod in your cluster. Well, this operator YAML file is what has the deployment definition to do that for you. These are some role-based access control assets. Molecule, I think Chris mentioned that earlier. Really fantastic set of testing capabilities. Excuse me. We're not going to go into that right now, just from a time perspective, but leave that as an exercise to you to come back to later. And then we have this roles directory and the memcached role. So already Operator.ck created us a basic role whose name corresponds to the custom resource and has the parts that we're familiar with. We've got the tasks directory with the main.yaml and a templates directory. And a default, right? We did a little bit of defaults already. We've got those things we recognize ready to go. They're empty, of course, but it's ready to go. And then we have a watches file, lastly. And already that watches file is set up. It's got the values that correspond to the CRD and this role. I mean, this thing is ready to go. We could run it right now. Granted, it's not going to do anything because there's no logic actually written in here, but we could run it and it would happily run that Ansible role in response to events and do absolutely nothing. So that's what you get with starting out. It's really quite comprehensive. For now, let's move forward. So don't forget to hit this change directory before we move on. And this project scaffolding layout is just giving you the tour that I just gave you. So we'll go ahead and hit continue. Now it's time to actually customize our logic. There's two ways we can go about this. The maybe more typical way is we could, with an editor, we could open up this tasks file and start typing out some tasks and doing it that way. But the second way we could do it is the easy way. And that's what we're going to do now, which is one of my colleagues, Dylan, created a role for us and put it on Ansible Galaxy. Now, Ansible Galaxy is kind of similar to like Puppet Forge or the Python Package Index or other similar kinds of global repositories where people share assets in a tech community. Ansible Galaxy, there's a tool called Ansible Galaxy. We're going to click this and run this command that it'll go retrieve that role Dylan created for us from Ansible Galaxy and install it here locally. That just happened. And let's take a look at what we got. All right, so we see these two, a new directory here in our roles. So we're going to go ahead and delete the one we don't want anymore, just to go ahead and get rid of that. And let's run this tree command to see what we have. Okay, there's a tasks directory with main.yaml. Now there's not a templates directory, so that's an interesting choice. Dylan decided to just inline his YAML right in that main.yaml file rather than using a template. Totally legit, works. We also have this defaults file up here. So we've got main.yaml where we could put defaults. And if we look at that, we can see that there's a default. He specified a size of 1. We've got that. And then we could also look at that task. And in the task file, there's exactly one task. You give it a name of start memcached. He's using the K8s module, providing a definition inline. Here it is, just a totally normal Kubernetes deployment. We're running the memcached container image based on Alpine, it looks like. All totally normal Kubernetes stuff. But you can see that we've templatized a couple things. The size is templatized, in this case replicas. And then check this out. The name and the namespace of this deployment are templatized. And this is very common, very typical here, and something that you'll want to do when you make your own Ansible-based operator. So when you create your custom resource, and we're going to do that in a minute, we're going to make a memcached resource, it's going to have its own name and namespace. That's called the primary resource, you may recall from what Matt was teaching earlier. So that primary resource is that memcached resource. Now we're going to create some secondary resources, for example, this deployment, and there could be other things, service, ingress, pod disruption budget, so on. Excuse me. They could all be secondary resources. Well, in addition to making all the secondary resources owned by the primary resource through owner references, we're going to use the name of that primary resource. In this case, meta.name, that's the actual name of the memcached resource that is currently being reconciled. And meta.namespace is the actual namespace of the current memcached resource that is currently being reconciled. So we can utilize those values to make the name and namespace for all of our secondary resources. So here we're just deriving that the name of this deployment is going to be whatever that is, -memcached. And then we do want it to be in the same namespace as our custom resource. So you'll see something like this very typically in your Ansible K8s module usage. Okay, probably enough of that. We can go down to correcting the watches file. Now, what's wrong with it? Well, we changed the path of where that role is because we brought in Dylan's role instead of the one that automatically got scaffolded. So we're going to go ahead and drop in this value. Now our operator will look in the right place on disk for that role. And by the way, the Docker file that got scaffolded out automatically puts your roles into this path in your operator's container image. Okay, so we're done with step 6, so we're ready to move forward. All right, now it's time to create our custom resource definition. And we can do an OC get CRDs, you're going to see an awful lot of results. Let's just search for example, because that's part of the group, the API group that we're, the name that we're giving to our API group, example.com, cache.example.com. Apparently feeling very creative when we made this exercise. So that doesn't exist right now, but let's go ahead and run this command and do this again, and we see already that our new API exists. That custom resource definition is there, and just like that, it's so easy. Every time I run this, I marvel at it, frankly, at how easy it is to add a totally new data type, a totally new resource type, an API endpoint to this API service with all the features around it. Create, read, update, delete, watch, all the eventing stuff is all just built in and ready to go, just that fast and easy. Kind of amazing and very powerful. It enables this whole controller pattern to go. I'm a fan. What can I say? I get excited. Okay, ways to run the operator. Let's talk about this real quick. There's 2 ways that you can run your operator. There's the production way and there's the lazy developer way. The production way is you're going to build a container image and run that in your cluster as a pod. That's how you would do it in production, across the board. That's just the right way to do it. As the lazy developer way, so when I'm sitting here developing on an operator, even if it's an Ansible operator, I'm going to change a little bit of code and I want to be able to run it and get quick feedback. I don't want to have to build a new container image, push it to a registry, do something to my pod or my deployment in the cluster to make it go refetch that image, like restart, start a new pod with a new image and wait for that to happen. And then I've got to go like run some other command to get the logs. I mean, it's just a lot of stuff to go through, right? I want to run it right here on my laptop. I want to see the output in my terminal on standard out. I want to be able to see the stack trace immediately. Did I fix the problem I'm working on or not? Like, I just want to go fast. I want to iterate fast. And so that's what Operator CK enables you to do with this run local feature. That's what we're going to do in this exercise because I think it's the more interesting use case, especially for those of you who either are going to actually embark on this and actually utilize Operator CK to make an operator, or maybe you have one or more teams at your organization that you're going to introduce to this. This is typically what they're going to be doing in their day-to-day workflow. So let's continue on to our 8th and final step. Now, the one caveat of running this locally is, as you recall, in that watches file, it's going to look in this absolute, file path for that role. Well, on this machine, like on my laptop, or in this case, in this environment, it doesn't exist. Terminal doesn't work quite the way I'm used to, but in any case, if I just say, like, op Ansible doesn't even exist. So what we're going to do is we're just going to copy, for right now, we're going to make that directory, we're going to copy Dylan's role in Ansible locally. It's going to be able to find that in our local environment. Yeah, that's just a thing you have to do. It's totally worth it. So you can read this, later if you want, but here we're going to create a new project in this wrap around a namespace. And now we're going to run this operator SDK run local, and we're going to tell it run the operator watching this namespace called tutorial. Here we go, and it's off and running. As you can see, it is written in Go itself, Go 1.13.3. We see normal operator things happening, leader election, and metrics are being served. All this kind of stuff that's just built into the operator SDK is already up and running, so that's great. Now we're going to open a second terminal window. Don't miss that part. Second terminal window. So come up here and hit this plus button right here above your terminal, and we can say open new terminal. Now we have a second terminal. We want to make sure that we hit this change directory command so we get in the right place on the file system here in our local environment. And again, remember that we have this example custom resource that got scaffolded out for us. We're just going to go ahead and create that thing. So I'm going to run this oc create-f in this namespace, that file. Okay. And now, what's going on? Let's come back and look at our first terminal. And we can see some output. Looks like Ansible is starting to run. It's gathering facts. We remember that. It's running Dylan's role. So what happened just now is that Ansible operator, it saw the event for that resource getting created. It ran Ansible providing the input from the custom resource. And Ansible ran, looks like a couple of times, and did some work. And hopefully, it created a deployment. It did. And we've got 3 pods up and running. That's how easy it was. We just went from I have a Kubernetes manifest to I have a role, now I have a whole operator around it, and we just used the Kubernetes API to say deploy this application with a size of 3, and it did it using Ansible and just really the templatizing features of Ansible. It's that easy to plug into this whole operator ecosystem and go Kubernetes native using operator SDK in Ansible. Now let's just do one last little fun thing to show off a little bit. So we can modify this file, this example custom resource. We're just going to increment this size to 4. How about that? Let's go crazy. Let's go to 5. And I'm going to save that. And I'm going to run oc apply that file. Come back here and look at what's going on. Okay. All right, so it applied it. Ansible's running. It's doing stuff. Now let's do oc get pods again. And there we go. All right, it's already going, and we see there's 2 new pods. They're only 5 seconds old. So there, that's how easy it is. Now create an API that is immediately reactive to changes. So you've got a controller running, and there's an API that other users and other pieces of software in your cluster can now utilize this API to deploy memcached and adjust the size up and down. And you can just imagine the other kind of things that you could put into that API to automate your more interesting and more advanced workloads than just memcached. Nothing against memcached. Speaking of memcached, we can get that resource and look at it. So we just did an oc get memcached -o YAML. We can see that there's the spec, size 5. We can see this generic status. The last time it ran, there were 2 tasks. Both were okay and nothing changed. This is the generic status. You could put more specific things in here if you want, but otherwise, the generic one at least gets you off the ground and is useful. That's basically it. That's where we're going to end this exercise. These last couple steps are really just cleanup, but these are throwaway environments anyway, so no obligation. You continue, and again, congratulations, you made it through this exercise. I'm going to hit more scenarios here, and I'll encourage you to come back. You can revisit these anytime you want, like I said. No sign up required, no anything, no email, totally anonymous. You can run these exercises. And there's this MC router. We affectionately call it the McRouter exercise because we're silly. But the MC router is another exercise you can run to see how you could use Ansible to make an operator do something a little more interesting. So I encourage you to run that. Of course, there's a lot of other exercises available. But with that, thank you for taking the time to follow along with these exercises. And Chris, I'll hand it back to you.
Thank you, sir. I appreciate that. Wonderful job with the exercises. Wonderful job, everyone, taking the time to go through this and present it to the world for everybody. If you have any additional questions, please feel free to reach out to me or anybody on the call today. We can help you out in the future. As I mentioned before, we have a Google group for Operator Framework where you can ask questions, and then go to slack.kubernetes.io, and there's a Kubernetes operators Slack room, whatever they call them, Slack chat there that you can use. And always feel free to go back to YouTube, and you can rewatch this stream for your re-education if you need it at any point in time, or if you want to share it with some of your coworkers or friends, feel free. And with that, thank you for coming to Building Kubernetes Operators with Ansible. I hope you've enjoyed your Red Hat Summit Open House experience, and I look forward to seeing you all in the future. Thank you.